In this module, we're going to describe another clustering algorithm called k-means. K-means, just like the other algorithms, start by computing a distance between each unit in our data set. So in this plot, we can see that we have about 150 different samples, and we are working in 2 dimensions. Dimension 1 on the x-axis, dimension 2 on the y-axis. And we want the algorithm to tell us which samples are in which clusters. Another thing we have to do with k-means is decide on the number of clusters we want at the end. That's what the k stands for. K is the number of clusters. So we have to, that is predetermined by the user. There are techniques to pick among different results from different k's, but you still have to start each one by defining k. So for this example, we're going to use 3 for this illustration. So we're going to tell k-means there are 3 clusters. So now the algorithm automatically has to put each sample into one of the 3 clusters. Notice that for us, just by looking at this, we can see what the answer should be. You can see there's 3 clusters, very clear, so you can say here, here, and here. However, we want the computer to do this. In practice, we might have to do thousands of these, and we can't look at each one separately. So that's how methods like this can be useful, even for simple data sets like this. So the first step is to pick 3 centroids, 3 centers for the 3 clusters. How do we do that? The standard approach in k-means is to pick 3 samples at random. So we do that, and we see the x's. The x's are the 3 points that were selected at random. Now for each point in the space, we figure out which of those 3 x's is closest. If the closest x, if this closest center is orange, then we make the sample orange. If the closest x is green, then we make the sample green. So now we have a cluster assignment for each point. And then on the next step, we do it again. But before finding new clusters, we're going to redefine the centroids. How? We're going to use the current approximation of the clusters to define a new center. So we take all of green points and we compute the dimension 1 mean, dimension 2 mean, and that is the new centroid. So now here it is. Here's the new x for the greens. It's over here. The new x for the purples is over here, and the new x for the oranges are over here. And now we redefine clusters again. Just find the x that's closest and use that color. So here's the next step. That didn't move much. We keep doing it. We keep doing it and doing it. And we see that the x's are slowly moving, and now they're getting closer to the center where we think they should be. And by the end, we have a pretty good result. So here it is again in a movie. You can see how in each step we get closer and closer to the center that we expect to be the correct answer. It's important to keep in mind that k-means selects its starting values at random. Therefore, every time you run it, you might get a different answer. It's also important to keep in mind that because you can select bad starting values, you can sometimes end up with a pretty bad final result. So these are things that are important to keep in mind. This is a powerful algorithm that works very well in general, but it does have its deficiencies, and it's sometimes useful to explore the data, explore the final answer to make sure that the algorithm worked well.